Okay, as we go through today, if you have any questions, please use the Q&A box, not the chat box. I can't see both the chat and Q&A, so we'll just use Q&A for any questions. Feel free to send them in as I talk. So today's presentation is on Wi-Fi 6. So today we're going to talk about our new models that we have out that are available right now through distribution. So we'll start with a little bit of background on Wi-Fi 6, and then we'll start talking about the products themselves. Let's go. Maybe. There we go. All right, so our foray into Wi-Fi started all the way back in 1997 when the first 802.11 spec came out. Back then there was no letter on the end. And the maximum speed was 2 megabits per second. And the reason I want to harp on this is because basically in all these years with all these changes, the core technology is basically based on that original 1997 spec. Now there have been some improvements, which is switching to OFDM back with 802.11a. And then carrying it on to 11G and some other stuff that we've done along the ways to make things better. But at the core, we're dealing with a lot of that same spec and the same underlying technology as we had back then. So we have things where, you know, back when that was spec'd out, they weren't expecting a lot of users. They weren't expecting things like video streaming. It was just a way of trying to get data to move, you know, small amounts of data from one computer to another. Speed wasn't a big deal. Reliability was a big deal. And because speed was low, because the available bandwidth was low, there was a lot of things that probably should have been done to make it forward ready that weren't. So Wi-Fi 6 is really the first major facelift to the Wi-Fi standard in all of these years. So we've been slowly making improvements, tweaking things here and there as we could. Wi-Fi 6, though, is really kind of like a rewriting of the spec itself and solves a lot of those issues for us. You know, one of the problems we've had in the past has been interference. You've only got so many channels available, and they cause interference if you've got too many APs in an area. There's no scheduling of devices, so it's kind of a free-for-all over who gets to broadcast at any particular time, which causes issues with drop packets and lowering performance. If you're more interested in a lot of that, join my Wi-Fi 101 webinar. We've got one coming up in July, and I go a lot more in depth into how Wi-Fi works and a lot of the issues that we run into and why we run into those issues. But Wi-Fi 6 has been designed to solve, I won't say all of those issues, but it has been designed to solve most of those issues. So with Wi-Fi 6, in theoretical terms, we can get up to 10 gigs Wi-Fi speeds. It's designed to have a larger capacity, both in the number of APs that can be in the same area, as well as the number of users that you can get on those APs. And these improvements that Wi-Fi 6 is rolling out are things that change the way the behavior on both the 2.4 spectrum and the 5 gigahertz spectrum. Whereas 11AC only made changes to the 5 gigahertz radio and how the 5 gigahertz works. So you didn't get any benefits with 2.4. With Wi-Fi 6, both 2.4 and 5 gigahertz are getting these new improvements. And when 6 gigahertz finally unlocks this fall, Wi-Fi 6 will also be able to carry over to that and any other frequencies that may get opened up in the future. So some of the technology changes we're seeing here is we're seeing 8x8 multi-user MIMO in both upstream and downstream variety. We've changed OFDM to OFDMA, the same technology that's used in LTE. We've allowed you to do resource unit scheduling, and we've changed the size of the resource units. We've increased the modulation so we can cram more data into the same bandwidth. We've added something called Bss Color Coding, which makes it so access points and other devices can know whether signals coming in are meant for them or not, or if they're bleeding over from other nearby devices, and something called TWT, target wake up time. So this is just kind of showing you here, OFDM is what we've been using since 802.11a and G. Basically, you've got 20 megahertz of bandwidth. So each user is going to use a 20 megahertz chunk of bandwidth. With OFDMA, we're allowed to dynamically break up these subcarriers and distribute it based on the capabilities of the client device or needs. So you're able to better allocate resources based on what needs to be used at that time for that device. With BSS color coding here, we help solve a lot of the co-channel interference issues that we've had in the past. The data packets have a little extra ID, which go through at the beginning of the packet, which basically identify who's supposed to be listening to that packet. So you don't get the interference from farther away access points. Instead, they're able to say, wait a minute, that transmission isn't meant for me. I can ignore that and I can start broadcasting now. It's actually intended for a different AP. And then just in general, we've got some big improvements here as far as performance goes. So in this scenario here, we're comparing 11AC to 11AX, both using an 80 megahertz channel and using 2x2 clients. So what you see here is as you increase the number of client devices here at the bottom of the chart, the aggregated throughput goes down. And this has to do with things we were talking about a little bit earlier before, where there's no coordination between the different client devices. So it's kind of a free-for-all. You end up with a lot of drop packets. You end up with a lot of devices waiting long and when they should have broadcasted sooner, things like that, which Wi-Fi 6 solves. So you can see with Wi-Fi 6, even as you increase the number of clients, the aggregated throughput remains pretty level. Versus with 11AC, as you add more client devices, you actually see the aggregated throughput drop. And then, this is showing you here on a per client basis how the throughput works. So if you go to 2 APs, you see the same sort of thing. It doesn't drop as much with 11AC, but 11AX or Wi-Fi 6 continues to remain flat, where 11AC the aggregated throughput starts to decline as you increase the number of clients spread across those 2 APs. And the same thing here. If we look at a per client device basis, you can get up to 6 times the throughput in some situations based on how many clients you have. So what we've got here is we've got 11N, now rebranded as Wi-Fi 4, 11AC Wave 2, now rebranded as Wi-Fi 5, and 11AX, now called Wi-Fi 6. So the maximum theoretical bandwidth for each of these standards is 600 megabits on 11N, 6.9 gigabits per second with 11AC, and 9.6 gigabits per second with Wi-Fi 6. So if we look at a 2x2 device, the maximum speed would have been 108 megabits per second with Wi-Fi 5, 11AC, 866, and now up to 1.2 gigabits per second with Wi-Fi 6. If we go to a 4x4 device, you're looking at 600 megabits with 11N, maximum 1.7 gigabits with 11AC, and up to 2.4 gigabits with Wi-Fi 6. So this is our upcoming roadmap as far as Wi-Fi 6 access points are going, at least in the next quarter or so. You'll notice here, these say July. These are available today. These have been skewed up at distribution, and distribution does have the ability to get their hands on at least a few of them today. Those will be more widely available in July, but they are available today. So today, we're just going to focus on the ones that are available now. So we'll start by talking about the NWA 110AX. Yes, we're changing the naming scheme. So it's a 2x2 device on both radios. It supports Nebula Flex, so it can be used standalone, or it can be used managed by Nebula. And it has built-in technology to help deal with cellular network interference, something we're seeing a lot more of as we see more and more small cells and things like that deployed inside buildings to help bring stronger LTE into the building itself. So the hardware looks like this. It looks probably very familiar to other breakdowns we've done in the past. As in the past here, to help deal with heat issues and to make the longevity of the solid state devices work longer, we've got a heat shield here in the back directly behind the PCBA designed to pull heat off the board and vent it out the top of the device. You will also see here we've got another heat shield / noise spreader here, and then our antennas are mounted on top of it. Unlike Ruckus and some of the other guys out there, we do not mount our antennas directly onto the PCBA. So by doing this and spending a little extra money to put this extra little shield here, it helps us with the signal to noise ratio. So it doesn't make a big difference on strong signals, but it makes a huge difference on those edge cases. And then like before on our other devices here, we've got a number of shields, generally more shielding than you'll find on our competitors to help deal with EMI on the board itself. All of the capacitors are solid state capacitors. There are no electrolytic capacitors to leak or boil over. Next up is the WAX 510D. Again, this is a 2x2 Wi-Fi 6 device. It features, though, dual optimized antennas. So if you're familiar with our WAX 6103DI or the NWA 1123 AC Pro, you're probably already familiar with this technology. And this is a Nebula Flex Pro device, so it includes 1 year of the Nebula Pro Pack out of the box. So you can use it standalone. You can use it, whoops, I got my slides out of order here, my bad. So this is talking about Nebula Flex. So Nebula Flex gives you the option to use the free cloud or to use it standalone. So the choice between Nebula Flex or between the two is just basically how you want to do management. So you can always switch back and forth between the modes, although configuration does not carry over as some of the features are different between the different modes. So here's a breakdown of that WAX 510D hardware. So very similar to what you saw before on the NWA 110AX. You'll notice here there are more antennas on the board here, and this has to do with that dual optimized antenna pattern we were talking about before. So this is trying to explain here what that dual optimized antenna pattern does. Your traditional access point is optimized to be mounted on the ceiling. The signal radiates out in pretty much an even pattern spreading out from where the access point is, aimed vaguely down. Unfortunately, you run into situations where you can't mount the access point on the ceiling. So instead you end up mounting it on the wall. So when you mount it on the wall, the signal is now being basically, rotated 90 degrees. So instead of a nice wide pattern covering an area underneath it, it's shooting a lot of that signal up to the ceiling and the floor. So you're not getting optimized coverage. So with dual optimized antenna situation here, we give you the ability to switch between two different sets of antennas. One set of antennas that's optimized for ceiling mount, one set of antennas that's optimized for wall mount. So you can switch which configuration you're using based on where you're mounting the individual device. So here are our competitors for the WAX 510D. Right now, our main competitors are the Aruba AP505. So if you're comparing us to them, it's a really nice comparison. They've just got static ceiling optimized antennas. We've got dual optimized antennas. We've got a little bit better power output than they do. But otherwise, the specs are very similar. The same gigabit Ethernet interface, 802.3 AT power. We also compete here with the Ingenious APs. The one thing I want to highlight here on the Ingenious APs is they are not truly Wi-Fi X. They are using an older chipset that doesn't support the full feature set that Wi-Fi 6 has in it. So we would call it a pre-Wi-Fi 6 or pre-11AX, although you're not going to really find that on their data sheet. So this is a good time to branch into this. When you are looking out there at products, what you're going to find is a lot of stuff out there doesn't support the full Wi-Fi 6 feature set. Basically, in the rush to be first to market, to be able to say, hey, I've got a Wi-Fi 6 access point, a lot of vendors launched with chipsets that we're going to call a Gen 1 chipset. So the main two chipset vendors are Qualcomm and Broadcom. I've got Qualcomm's feature set up there. It's very similar for Broadcom. Basically, Qualcomm came out with a couple different Gen 1 chipsets over time. But those Gen 1 chipsets don't have the ability to do the upstream OFDMA. They don't have the ability to do upstream MIMO. They don't have the ability to do TWT or Bss color coding, which are key technologies for higher density deployments. And some of the key things here which make Wi-Fi 6 so much different than 11AC in real world scenarios. So the Gen 2 chips support the full Wi-Fi 6 feature set, and the Gen 2 chips didn't launch until late last summer, early fall, for both Broadcom and Qualcomm. So when you go look at data sheets for different APs, you're not going to see them point out the fact that they're using these pre-chipsets that don't support the full feature set. So there's two ways you can tell if you're getting Wi-Fi 6 or not. The main way is to just look at the features on the data sheet. If they don't mention some of these technologies, like Bss Color Coding, it's because they're probably using a Gen 1 chipset that's not going to support it. The other way is just when did the device launch? Since the chips weren't available until the end of summer, early fall last year, any product that launched before then is going to be using a Gen 1 chipset and missing some of those features. Now, it's not a big deal today because there's not a lot of Wi-Fi 6 client devices and not all of them support all of these features yet. But in the future, 2 years down the road, it's going to make a big difference whether you've got a true Wi-Fi 6 product or whether you've got something that's based on a Gen 1 chipset. So everything Zyxel is launching with Wi-Fi 6 is using the Gen 2 chipset and either has all of these features or will have all of these features via free firmware update in the future. So for comparison here, we did some performance testing comparing us to the Aruba AP505. So you can see they're in blue. Since this is a dual optimized antenna, we've got two different antenna patterns to use. We've recorded throughput using each of the different antenna patterns. The darker orange here is for wall mount. The orange is for ceiling mount, and we did our performance tests with them. As you can see, for both throughput and reception, we outperformed or matched the performance of the Aruba access point. So that was on 5 gigahertz, same story here on 2.4. So the WAX 510D supports Nebula Flex Pro. So the NWA 110AX is Nebula Flex. 510D gets you Nebula Flex Pro. So those of you that aren't familiar with the difference, Nebula Flex, as we talked about, gives you the option to use the cloud to manage your devices or manage them directly. Nebula Flex Pro also allows you to manage the devices using a controller. So we have our NXC series of controllers you can buy. Also, almost all of our Zywall models, whether it's USG or ATP, have a built-in wireless LAN controller you can use if you want local management. The Nebula Flex Pro devices also include 1 year of the Nebula Pro Pack, which unlocks additional features in the cloud. And then you can either choose to renew that at the end of 1 year, or it'll just fall back to the free version of Nebula after that. So it's up to you how you want to manage your devices, which you're most comfortable with. The cloud is the easiest when it comes to setting it up, managing and monitoring it. But we understand there's a lot of you out there that just don't want to or don't trust the cloud, or maybe your customers don't trust the cloud, or you just prefer some of the extra features that maybe are available in the controller managed mode that aren't yet available in Nebula. Our next AP today is the WAX 650S. So this is a 4x4. So the other ones we were talking about were 2x2. This is a 4x4. So you've got twice as many spatial streams. This includes our smart antenna technology. It's got 5 gigabit Ethernet uplink and is Nebula Flex Pro. So you can see what it looks like here. It does have a DC power jack, and I'll explain a little bit why in a few slides here why that's important. But it's got 5 gig for the input, and then you've got a 1 gig coming out. So you can daisy chain it to another device over 1 gig. And again, very similar breakdown of the component and design as our other ones. We've got the heat spreader and shield design. We've got the APs mounted to the shield, not directly to the PCBA. We've got the heat sink behind the PCBA and copious vent holes to help pull heat out. So that helps ensure the longevity of the device by getting rid of one of the main causes of failure on a solid state device, which is heat fatigue. And then we're using the solid state capacitors again, which is probably the second most common cause of failure on a solid state device, is capacitors leaking or failing. So we help reduce that as well. This device also has a third radio. So you've got one radio for 2.4, one radio for 5, and you've got a third radio which provides Bluetooth connectivity for Bluetooth low energy applications. Oops, sorry, I confused the two. We've got the Bluetooth radio, and we've got an additional third Wi-Fi radio for performing site scanning to help monitor the environment without interfering with the 2 radios being used for data transmission. So this does have our smart antenna technology in it. We'll briefly go through that for those of you that haven't heard this a million times already. Smart antenna technology is designed to reduce interference. It's designed to increase capacity and increase the coverage area. So traditional access points are designed to be mounted on the ceiling. They've got one antenna pattern that's sort of a round antenna pattern, or you've got your directional access points, which generally have an antenna pattern that's designed to focus the beam in a certain direction. So here you've got your traditional access point, and you've got another source of interference. So this could be, another access point. It can be your neighbor's access point. It can be another 2.4 or 5 gigahertz device. It can be a microwave or other industrial equipment which causes interference. With smart antenna, rather than having one fixed antenna pattern, we have the ability in real time to switch between hundreds of different antenna patterns. And our algorithm takes a look at not only where the client device is in relation to the access point, but also where other sources of interference might come from, and then tailors that antenna pattern to not listen to sources of interference and to focus the beam on where the Wi-Fi client device is. So this works with both static and moving devices, and gives us the ability to help deal with those sources of interference. It allows us to crowd more APs in an area, and it allows us to have more wireless devices in the area. So this is a hardware way of solving some of the same issues that Wi-Fi 6 solves from a protocol or standards way. And rather than replacing them or making one obsolete, they team up together. So you get even better performance than you would without the smart antenna technology. So here's a list of our competitors. We've got the regular Cisco Catalyst AP, the Cisco Meraki MR45, Aruba's AP535, and the Ruckus R750. Only us and the Ruckus have the smart antenna technology. I'll tell you our smart antenna technology is a little bit better than theirs when it comes to dealing with interference. We've got the highest output power of any of our competitors here. So we're going to give you better, stronger signal. All of us are 4x4. And only us and the Aruba and Ruckus have the pass-through 1 gig port LAN port. Cisco does not provide that. And we're pretty much the only ones out here that are offering free cloud, paid cloud, standalone, or controller operation. Your choice what you want to use. So when it comes to performance here, we got the Aruba. So we're comparing us to the Aruba. Now, to be fair, the Aruba is only a 2x2 on the 2.4 gigahertz radio. So it's a little bit unfair there. So since we're 4x4, they're by 2x2, you would expect a little bit better performance, and that's what you see. However, on 5 gigahertz, we are both 4x4. And again, you will see a huge difference in performance, even though in theory, we both have the same specs on the 5 gigahertz radio. So just to try to highlight here, both of these APs are a 2x2. So in Wi-Fi 6 parlance, that gets us 17.75 megabits per second maximum data rate across both of those radios. By going from the NWA 110AX to the WAX 510D, you get dual optimized antennas instead of just the standard ceiling mount antenna, and you get Nebula Flex Pro. So you get a year of Pro Pack if you're using Nebula, or the ability to use a controller to manage your AP. When jumping from these two models up to the WAX 650S, number of improvements. First one's going to be a 5 gigabit Ethernet port. Right, so if you look at speeds, we're going from 1775 to 3.5 gigabits per second. So a 1 gigabit Ethernet port really isn't going to cut it. So we give you a 5 gigabit Ethernet port there for the uplink connection. We're giving you the smart antenna technology. We're giving you that third radio, and we're giving you a fourth Bluetooth radio all in the device. So that's what the steps up are as you go from one to the next to the next. So one thing I do want to highlight here, for that WAX 650S, you really need to pair it with our XS1930 switch. The WAX 650S requires the new BT 802.3 BT PoE standard, which provides up to 60 watts per port. So we've only got 2 switches currently that provide that. We have the NWA 1356 HP, which can provide 1 port of 60 watt power, and our XS 1930 12 HP here, which can provide multiple ports of 60 watt power. So you can power multiple APs, multiple WAX 650S APs. In addition, as we mentioned, in order to get maximum performance for throughput, you need a 5 gigabit Ethernet connection. So this supports multi-gig and provides 5 gigabit or 10 gigabit Ethernet connections. So really good idea to pair the two. So a common question is, okay, Sean, I can't afford it. My customer's got an existing switch. What happens if I plug in the WAX 650S to that? So it will still work with a 1 gigabit Ethernet connection. It will still work with 802.3 AT-PoE, but it will throttle itself so it doesn't exceed the 802.3 AT-PoE power draw. So you end up losing a lot of your performance. One way around that is you can add a external AC power adapter. We sell those. They're, I think, $15 or $20, somewhere in that ballpark. And then you can just plug it in directly to AC power to get the full wireless performance on the speed. So those are your options there. So ideally, the best choice is XS1930. Other choice is the GS1350 HP, 6 HP, or using an AC power adapter. So with these new APs, we have also launched a new mounting bracket. So this is different than our previous mounting brackets. This is much more flexible, so it gives you the ability to mount it onto a ceiling or wall. It gives you the ability to use clips to mount it to your drop ceiling T-rails. And it also now allows you to directly mount it to either a round junction box or a standard power outlet type junction box. So really flexible with where you can now mount our APs. This comes in the box, not like some of our competition where you have to buy different mounting brackets based on where you're going to mount it to. We have one universal mounting bracket now, which works in basically any scenario you run across. We have a little animation there. Forgot about that. So that's it today, guys. That concludes our sort of introduction to our new Wi-Fi 6 access points. If you have any questions, send them in via the Q&A interface. While we're waiting on that, I do want to draw your attention to the fact we do have a user forum, forum.zyxel.com. You can go there and you can talk with your other users, post suggestions, get help troubleshooting or figuring out how to configure things. And unlike a lot of our competitors' user forums, our user forums are actually monitored by our R&D and engineering teams, and they will jump in and provide feedback for you. Also, you know, if you have questions, if you have feedback on today's webinar, if you have ideas for other topics and things you'd like to see me cover in the future, feel free to go ahead and email me. My email's right there. It's really easy. It's seanr@zyxel.com. And let me know. I'm not seeing any questions. Greg did send me a message here. I can see that. He's asking for pricing. So the NWA 110X AX pricing, ballpark, it's going to be about $200 per AP. The 510D, I believe, is around $250 per AP, and the 650S is around $600 per AP. So those are the ballpark prices. Obviously, reach out to your distribution guy, and they can get you exact pricing. This has been skewed up at all of our major distributors. So Ingram Micro, D&H, Cynix, Target, I believe Wave it's been skewed up at. So all of them should have access to it. They may not yet have ordered stock in, but they should be able to, you should be able to push your sales guy. He should be able to get you pricing. And he should be able to get his hands on these for you, whether it's drop shipping them for you or pulling them into their warehouse to ship out. They have been skewed up. They are there. They are available for you. Again, right now our stock's kind of limited, but by mid-July, we should have no issues on stock. But for most of you, we should be able to get these to you. Let's see here. We have got a question here. Will this be posted online later? Yes, so this will be automatically posted to the Zyxel America channel or Zyxel Channel America YouTube channel. We have links to that from our website. We can just go to YouTube and type in Zyxel channel and it should come up. So this will probably be posted probably later today, but should be no later than tomorrow. Dave is asking about controller pricing, and controller pricing, that really varies based on what sort of controller you want to be using. We've got two dedicated controllers, the NXC 2500 and the NXC 5500. So the 2500 does up to 64 access points of management, 8 out of the box. Then you buy licenses to expand it. The 5500 starts with 64 APs and can be expanded to manage up to 1,000. And then our Zyxel series, it just depends on the model. Most models support at least 2 APs out of the box, and then you buy one-time licenses to expand that. So it just depends how you're managing it, and how many APs you need to unlock, what the price is going to be. So your salesperson can help you figure that out. Jacob or Ivan, just reach out to them. They can help you. If you want to use a controller, they can help you figure out which is the best option for you, and figure out which licenses you need, and pass that on to distribution to get you exact pricing. And I am not seeing any more questions. I will stick around for just another minute here in case someone's working on something. But otherwise, guys, just highlight your question, copy it, and just paste it into an email to me. Again, it's seanr@zyxel.com. I will do my best to answer those questions for you via email. If you don't get an answer from me within 24 hours, send it again. We've got at our office here, we've got multiple anti-spam filters. So it's always possible. I check my spam filters, but with 3 of them to check, it's always possible it got caught in more than one and I missed it. But you should be able to reach out to me. And, if not, you can call me at the office. Just call the main office number. I'm in the directory, extension 202. Or you can reach out to your salesperson, Jacob or Ivan, and they can pass along the question to me. They for sure are not going to get caught in our spam filters. They've been whitelisted. Okay, guys, I don't see any more questions. I'm going to go ahead and end today's webinar. Thanks for joining us. I appreciate you guys taking the time to join us and learn a little bit about our new products. And again, feel free to email me with suggestions for other presentations you'd like to see us do in the future.